Drilling a well is a complex critical stages to ensure the successful extraction of clean and safe water. Each stage is meticulously planned and executed to address the geological and environmental conditions of the site. Here are the main stages of drilling a well using a drilling rig. 1. Site selection. Choosing a suitable location for the well is the first and one of the most crucial steps in the drilling process. The site is selected based on various factors including accessibility. The site should be easily accessible for drilling equipment and future maintenance. Geology. The geological characteristics of the site are assessed to determine the best drilling method and to estimate the depth required to reach a reliable aquifer. Proximity to contamination sources. The site should be far from potential sources of contamination like septic systems, agricultural runoff, and industrial waste to ensure the purity of the water. 2. Permits and regulations. Before drilling begins, it is essential to obtain the necessary permits and adhere to local regulations. This step involves permit acquisition, submitting applications and obtaining the required permits from local authorities. Compliance with regulations, ensuring that the drilling process complies with local, state, and federal regulations, including those concerning well casing depth and environmental protection. Special requirements, addressing any specific conditions or requirements listed in the permits, which may include additional measures for environmental protection or water quality testing. 3. Drilling. The actual drilling of the well is performed using a drilling rig and can vary in method depending on the site's geology. Mud drilling, used in softer geological formations where a mixture of water and drilling mud is used to cool the drill bit, remove cuttings, and stabilize the borehole. Rock drilling, employed in harder geological formations, often involving the use of specialized drill bits capable of penetrating rock layers. 4. Casing and grouting. Once the desired depth is reached, the well is lined with a casing to prevent collapse and contamination. Casing installation. Steel or PVC pipes are installed in the borehole to keep it open and to provide a conduit for water. Grouting. The annular space between the casing and the borehole wall is filled with grout, a mixture of cement and water, to seal the well and prevent surface contaminants from entering the water supply. 5. Abandoning existing wells. If a new well is replacing an old one, the existing well must be properly abandoned. Grouting the old well. Pumping grout into the old well from the bottom up until it is completely filled to ensure it no longer poses a contamination risk. 6. Well development. After drilling and casing, the well undergoes development to improve water quality and flow. Clearing the well, removing fine particles, debris, and drilling fluids from the well. Enhancing water flow, techniques such as surging, airlifting, or using chemicals to increase the permeability of the aquifer and improve water flow into the well. 7. Water testing and treatment. Testing the water quality is crucial to ensure it is safe for consumption. Initial testing, conducted by the well drilling company to check for basic parameters like bacterial contamination, turbidity, and mineral content. Regulatory testing. Some regions require additional testing by local authorities to ensure the water meets safety standards. 8. Installation of pumping equipment. Once the well is developed and the water quality is verified, the pumping equipment is installed. Pump installation. A submersible pump or jet pump is installed to bring water to the surface. Associated equipment. Installation of components such as pressure tanks, control switches, and piping to ensure a reliable water supply. 9. Comprehensive water analysis. For a thorough assessment of water safety and quality, a comprehensive water analysis is often conducted. Detailed testing. A water treatment technician tests for a broader range of parameters, including pH levels, iron content, hardness, and the presence of other contaminants. Treatment recommendations. Based on the analysis, recommendations for any necessary water treatment solutions, such as filtration or softening systems, are provided to ensure the water is safe and suitable for use. Each of these stages is vital to the overall success of the well drilling process, ensuring that the final product is a reliable, efficient, and safe source of water for residential, agricultural, or industrial use.
That's the real secret. What you may not realize is just how efficient such a simple innovative system is, as it interested the need of buying expensive bottled water or going through the hassle of drilling a new well. And thanks to this breakthrough technology, you can now literally drink from the enormous lakes in the air. The water is purified and the unique system can produce up to 30 gallons of clean, fresh water a day, and you won't have to worry about all the nasty chemicals ever again. The fundamentals are so easy, and if properly applied, you can have a virtually unlimited water supply anywhere, even if you live in the desert.